So like I always like to do, last part of the word problem says find both women's walking speeds. So we can keep that in mind. We're looking for two different speeds, two different rates. Elvira and Alethea. You guys can let me know if I'm mispronouncing those. I'm sure I am. But they live 3.1 miles apart on the same street. They're in a study group that meets at a coffee shop between their houses. So I think I know what we're getting set up for. The first person's house, they're going to do some traveling. And the second person's house, I don't know, let's make it a different color, because we have the technology to do that. The second person, they're traveling towards each other to meet up at this coffee shop. And it might be that the red line is supposed to be longer. We don't know that yet. We know they're traveling towards each other. Elvira, it took Elvira half an hour, and Alethea 2/3 of an hour to walk to the coffee shop. And so we want to know something about the speed. Then that means we can use the distance equation to help us find that speed. The distance that you travel is equal to the rate you're traveling at times the time it takes you to make that travel. And so we could add these two distances to each other. Right? This distance is some rate, and I'm going to call it r sub 1 because there's two different rates going on in this problem. We want to distinguish them. Elvira's rate times Elvira's time. It took her half an hour, so I'm going to write 0. Let's use a fraction, actually. So the rate times time. And if we add that to the distance that Elvira travels, that's a different rate. So we're going to call that r sub 2. Times 2/3, so times 2/3. If you add those two distances together, it should make the full distance between their houses, 3.1 miles. So it's tempting to try to get common denominators in this equation, but look, this is r sub 1, and this is r sub 2. So they don't match, right? They're different. You could think of them as an x and a y. They can't add together. So we need to go back in the word problem and find something that tells us how to relate these two things to each other. Alethea's speed, which we let be r sub 2, Alethea's speed is 0.6 miles per hour slower than Elvira's speed. So this is Elvira's speed. We're not going to replace that with anything because it's Alethea's speed that can be rewritten as Elvira's speed, just 0.6 miles per hour slower. Okay, Alethea's speed is Elvira's speed subtracted by 0.6 miles per hour because it's 0.6 miles per hour slower. Now we have an equation all with the same type of letter. It's all r sub 1. So now we can solve. So we can distribute 2/3 to everything inside the parentheses, and I'm just going to rewrite this as 1/2 r sub 1. So 2/3 times r sub 1 just gives us 2/3 r sub 1. And then 2/3 times 0.6. You can do that with your calculator if you want. So 0.6 times 2 divide 3 gives us 0.4 here. And so we could combine these. Maybe the decimal approach works best. If you do 1 divided by 2 in your calculator, and if you do 2 divided by 3, I'm going to use 0.667 as an approximation. And then we want to add these together. So 0.5 plus 0.667, it's 1.167. So you want to add that 0.4 to both sides. So we get, that's my poorly drawn arrow, geez, that's bad. So we get 1.167 r sub 1 equals 3.5. So divide both sides by 1.167. So r sub 1 equals 3.5 divided by 1.167. So that's 3 if we round. Okay, so one person's speed is 3 miles per hour. And that was r sub 1, Elvira's speed. So that means Alethea's speed, which was r sub 2. Alethea's speed is 0.6 miles per hour slower, so it's 2.4.